Let's go ahead and get started. Before we head to space, I want to tell you just for a few minutes how I got here, how I became an astronaut. I was just 6 years old when the first American astronaut launched into space. That was a long time ago, May 5th, 1961. And at my elementary school in Cleveland, Ohio, they brought us all to our gymnasium. I sat on the floor and I watched the small black and white TV of the launch. And as soon as our astronaut had made it to space, I remember sitting there saying, I want to do that. So ever since I was 6, I knew I wanted to be an astronaut. I wanted to ride a rocket. I wanted to experience zero gravity floating around up there. So I always knew what I wanted to do. The problem is, well, how do you get there? How do you become an astronaut? And as a young boy, I wasn't sure how to do this. We only had 7 American astronauts at that time, and I didn't know any of them. But the one thing I recognized early on was it was going to be difficult. There was a lot of competition. Thousands of people apply to be an astronaut, and then a small handful get selected. So I knew as a young boy, my only shot of ever making it to space would have to involve me working hard and doing my best in school every single day. By chance, have you ever heard that advice before? Work hard, do your best. Work hard, do your best. Have you ever heard that? Like once or twice, or like a million times? A million, right? It is really good advice because you never know when something you're learning today is going to help you in the future. So all through school, I tried to do my best in math and science, but reading, art, history, music, gym, language, whatever I worked on, I tried to give it my best effort. And when I was in elementary school, I was an average student, getting mainly B's, a few C's, and a few A's. When I was in junior high, I was working a lot harder on my schoolwork, getting A's and B's. And by the time I got to high school, I was really focused on my schoolwork and got nearly straight A's. I had 1 B and the rest A's. And I got those grades not because I'm the smartest person in the world, but because I worked really hard. I have a fraternal twin brother who's like a genius. He never had to study, and he got perfect scores easily. I was one of those students that had to read the chapter, read it again, talk to my teacher, study some more. But in the end, I learned everything I needed, and I learned how to work hard, which was a great skill later on in my career. So after high school, I went on to college. I got my bachelor's degree in physics, one of the sciences, and that was the minimum degree you need to become an astronaut, 4-year college degree in math, science, engineering, or the medical field. But again, I knew the competition was going to be tough, so I decided I'm going to stay in school, and I got my master's and my doctorate in engineering. So after 9.5 years of college, I got out. I took a job with a company called AT&T Bell Laboratories doing research work in New Jersey on the East Coast, outside of New York City. And this was in the early 1980s, just when we were starting to launch the shuttle program, so my timing was perfect on all of this. Now, NASA selects new groups of astronauts every 3 or 4 or 5 years. They'll pick a small group of 10, 15, or 20, depending on their needs. And 2 years after I got out of college, NASA put out the announcement they needed new astronauts. I was all excited. I wrote to them. I got the application form. I carefully filled it out. I sent it back in, and guess what happened? Rejected? You guys have no faith in me, but you're absolutely right. They said no thanks. And I was surprised by that, but I didn't give up. 2 years later, they had another astronaut selection. I got another application form, filled it out, sent it in, and then that second time, who said rejected? You're right, I got turned down again. And at this point, I was thinking, you know, my grandmother and I have the same chance of becoming an astronaut. What chance was that? 0. I wasn't even getting close in the competition. So at this point, I realized I needed to do more to get noticed by NASA. And being an engineer, what I did is I studied the data. I carefully looked at the backgrounds of the people that were successful getting into the program to try to see, what do they have that I don't have? What am I missing here? What education, what background, what experiences? And by carefully studying that, I learned a few things. The first was most of the civilian astronauts they were selecting already had flying experience. It wasn't a requirement, but it seemed to help a little bit. So I started taking flying lessons, and I got my pilot's license. I also noticed most of the astronauts had some parachuting or skydiving experience. It was not a requirement, but it seemed to help. So I learned to do that. And then I also noticed that, most of them had done some teaching, had some experience doing that. So I went ahead and taught a university course. So I worked on these activities. 3 years later, they had another astronaut selection. I sent my application in, and this time NASA called me up and they invited me down to the Johnson Space Center in Houston, Texas for a week of medical testing and an interview. And out of the thousands of people that apply to be an astronaut, NASA will select 100 individuals, they bring you to Houston, and you spend a full week on a very thorough medical exam, and then there's a 1-hour interview. I passed all the medical tests, that went well. I went on to the interview, and that went extremely well. And at the end of my week with NASA, I thought, boy, that couldn't have gone any better for me. And I went back to my job in New Jersey there, and I just sat waiting to see did I make it or not this time. And I was back at my job about a week or so, and some of my friends started calling me up from across the country. And they called up and they said, hey Don, the police have been calling about you. And let me tell you, if the police are ever calling about you, it's either really good or really bad, right? In this case, it was really good. NASA was doing a security background check on me. And they looked into my background. They checked the police records in every city wherever I lived to see if I'd ever been in trouble. They went and met with every boss, every company that I worked for, from high school on, and talked to my former bosses, and they would ask them, what kind of worker was I? Did I show up to work on time? How did I treat the customers? How did I treat my coworkers? And then they went up and down the streets in all the neighborhoods, wherever I lived, talking to the neighbors, asking about what kind of person was I and how did I treat people in a neighborhood. When I heard that was going on, I thought this is a great sign. I didn't think NASA could be doing this detailed security check on all 100 people. I figured they must have selected their astronauts, and this is the final security check to make sure you're good to go before they announce the names. So I was pretty excited, and it was 2 months later I got the phone call from NASA. They called up and said, Don, thank you very much for applying. We had a lot of good candidates. We did not select you, but good luck in the future. And I hung up that phone and I was in shock. I thought I had made it in, but here for the third time, NASA said no. First time, no. Second time, no. Third time, they interviewed me and got to know me, but the result was the same. And so at this point, I realized it's time for me to give up on this silly dream of mine, right? I gave it my best shot. I worked hard. I applied 3 times, and clearly NASA didn't want me. So I decided I would go to bed, get a good night's sleep, and then in the morning when I woke up, I would put together a new plan for my career that did not involve being an astronaut. So I went to bed that night. The next morning when I woke up, the very first thought that popped into my head was, I still want to be an astronaut. So I asked myself again, are there any more of these little things that I can do to improve my background, to make myself a better candidate? And once again, by carefully studying who they were selecting and who they weren't selecting, it was pretty clear most of the civilian astronauts NASA was selecting, they were individuals that were already working at the Johnson Space Center in Houston. So I quit my job, I drove halfway across the United States down to Texas. I got a job with NASA as an engineer working on the Space Shuttle program. Did that for 3 years. Then they had another astronaut selection, number 4. I sent my application in. I got called up for the medical testing and the interviews, and that went well once again. And then it was about 3 months later, I got another phone call from NASA. And this time they called up and said, hey Don, are you still interested in being an astronaut? Because we'd like to offer you the job. I said yes. I hung up that phone and I was just jumping up and down, yelling and screaming for 10 minutes because I knew I made it into the program. I was 35 years old when I got that call, and I started a 4-year training program for my first flight. So the first time I made it to space, I was 39 years old. Now 39, that's pretty much an old man, right?
No.
Yes or no?
No.
This is a good group. Very good group. Okay, you guys can stay. You can graduate today, right? But some of the careers you're going to pick, it's going to take time to get there. So I have a quick question for you just to start off. What do you think the lesson is from the story I just told you? Raise your hand if you got it. Go ahead.
Well, it can take time, but never give up.
It could take time to get there and never give up along the way.
Work hard and do your best.
Work hard and do your best. This stuff does not come easy. You gotta work hard and you wanna do your best. Every single day, or like Monday, Wednesday, Friday.
Every single day.
Every single day you wanna be working hard, doing your best. Go ahead.
Always try to improve.
Always try to improve yourself. You know, you're gonna get rejected in life. Everybody does. So when that happens, you wanna look for things that you can do to improve yourself. Maybe you gotta get help from your teacher, but find out what you're missing and try to improve yourself always. Anybody else? Go ahead.
Don't focus on bad things. Also, you can live for everyone.
Say it one more time.
Don't focus on bad things. You can also live for everyone, for every candidate.
You can, I'm missing.
Learn from all of the candidates.
Learn from other candidates.
Yeah.
Yeah. You want to be smart about it. One last one here.
Make your research, don't be envious of other people, just try to get inspired by them and try to improve by taking them as an example.
Yeah, you guys hit all the main points here. I'm going to tell you what it's like in space, but the one thing I want you to remember over everything else that I tell you today is to work hard, do your best, and never give up on whatever your dream is in life. I almost gave up on my dream after NASA turned me down that third time, and had I given up at that moment, I wouldn't be with you here this morning. So really, you know, that's the one message I want you to leave here with is never give up on your dream. So I went from this little boy just dreaming of going into space to getting assigned on 4 space shuttle missions. This is the crew from my last flight, and the last time I was in space was 25 years ago aboard Space Shuttle Columbia. We have 7 astronauts on the crew, 2 military pilots in the front row that help us fly the shuttle. On the left-hand side with the helmet is our commander, Jim Halsell. He was an Air Force test pilot. He used to fly the SR-71 Blackbird spy plane. And we have one of those here at the Space and Rocket Center. I'm sure you guys have seen that. On the right-hand side with the helmet there is our pilot. Her name is Susan Still. And Susan was a pretty unique individual. She's only the 2nd woman to pilot the space shuttle. And Susan was one of my country's top Navy fighter pilots. So it was really a great opportunity for me to fly with her on this mission. And then in the background, we've got 5 of our science astronauts. We're called mission specialists and payload specialists. And our job is to do the science on board. We're trained to work the robotic arm on the shuttle if there's a need for that. We deploy satellites and do spacewalks. So we each have our area of specialty on the crew. You probably don't recognize that guy on the far right-hand side, but that's the way I used to look 25 years ago before glasses, gray hair, wrinkles, and a few pounds around the middle here. I heard that. Okay.
I remember that.
Here you see the space shuttle on the launch pad. I took this picture the night before my first mission. Went out there about midnight or so with another astronaut. And it was so amazing to stand there right at the base of your space shuttle, all lit up with the bright lights against that pitch black sky. And as I stood there gazing up at it, I had incredible butterflies in my stomach. Do you know that phrase, butterflies? Yeah. Just a little piece of me was nervous, a little piece of me was scared, but my main emotion was just one of great excitement because I knew 12 hours from when I'm taking this picture, I'm going to be sitting right in the nose there blasting off. And I almost couldn't believe where I was and what I was about to do. So they bring us out here on launch morning. We take an elevator or lift up the side here, and there's a little access arm we walk across. We crawl to a round hatch or door to get inside the shuttle. So here I am in my launch suit 3 hours before liftoff. I've taken the elevator up. You see Space Shuttle Columbia there in the background. And they strap us into our seats one at a time. So I'm just standing outside here waiting. When it's my turn, they'll call out and say, "Hey Don, we're ready for you." I'll turn that corner to the left, walk down that access arm, and at the end of it there, you see the round hatch or door for the shuttle. Before I climb inside, these 2 gentlemen in the white suits will help me put on a parachute harness. They'll check all my equipment, and once everything looks good, I get on my hands and knees, crawl on that white board, go inside, and there's a few people that help strap us into our seats. We're sitting in seats similar to what you're sitting in today, but because the shuttle is tilted upright for launch, we're actually laying down on our backs. And we've got shoulder harnesses and seat belts. They strap us in good and tight because there's a lot of shaking and vibration during launch, and you don't want to bounce out of your seat and hurt yourself or damage any equipment. So they strap us in nice and tight. Once that's all done, they close and seal that side door, and then everybody moves away from us about 5 kilometers. And it gets very quiet inside the shuttle up until 6 seconds before liftoff. At that point, 3 big engines at the tail of the shuttle here start coming up to full power. And 6 seconds later, we light our big white side rockets called solid rocket boosters. And the instant they light, boom, immediately you take off. So I'm laying on my back in Florida, everything is quiet. 6 seconds before liftoff, I can hear the roar of the engines as they come up to full power. A lot of shaking and vibration going on. And right at the moment of liftoff, I felt a push in my back once we had lit the solid rocket boosters. And it felt to me like somebody had their hand in the middle of my back and they were just pushing me up into the sky. And that's what the shuttle's doing, literally pushing us, tossing us up in the air. This picture is taken 4 seconds after liftoff. We're going 200 kilometers an hour already. So we don't ease off the launch pad. It's literally boom, and you accelerate faster and faster every second. 8.5 minutes later, the engines shut down. It's perfectly quiet, and you're in space. It only takes 8.5 minutes to get to space. I bet it took you 8.5 minutes to get from wherever you were before into the theater here this morning, right? And think about that, in that short period of time, in 8.5 minutes, you could end up being 300 kilometers above the Earth. And at this point, we're traveling at a speed of about 27,000 kilometers an hour. That's like 7 kilometers a second. So think about how fast you can get home when you graduate from here. You know, most of you'd be home probably in maybe 30 minutes or so. And we go so fast that we travel all the way around the Earth in only an hour and a half. So in the hour that we'll be together this morning, if we were in space, we would travel 2/3 around the planet during that time. On 3 of my 4 missions, we had a science module right here called Space Lab. And this was managed out of the Marshall Space Flight Center, and I did many, many months of training here. And I have a good friend, Ruby Runt, in the front row here, who helped train me for these missions. And they were special Space Lab missions. We had, I think, 22 of these or so during the shuttle program. And once we got to space, we'd open up a hatch and we could float through the tunnel and go back there and work on different experiments. So there I am and Greg Lantiris, another astronaut, working back in our science module. I want to tell you quickly about 2 of the experiments to give you an idea of some of the work we do in space. I think everybody's familiar with the shape of a candle flame. You know how it comes up to a point? Anybody here know why it comes up to a point like that?
Gravity?
Gravity's important. What does hot air do here on Earth? Hot air rises, right? It's lighter, less dense, so hot air rises. And it's that hot air rising from the candle flame that draws the flame up to a point. You put your hand above that flame, you'll feel the heat rising. You put your hand below it, it's much cooler. Well, in space, without gravity, you know, that hot air doesn't rise and cold air doesn't settle. So in space, a flame will burn perfectly round, as you see here. And what you're looking at is a little pink droplet of butane fuel. It's like what we have in a disposable lighter. And we've set it on fire, and that blue ball or halo you see there is the flame burning. And it'll just float in the air. It'll burn perfectly spherical, as you see here. And it'll burn up all the oxygen around itself, and that flame will go out all on its own. Scientists are studying things like this. They're trying to understand some of the basic fundamentals of combustion. How do things burn, and what happens when we get incomplete combustion, when we get soot particles and other pollutants. And maybe from these experiments in space, we can improve our burning processes here on Earth for our power plants, our automobiles, things like that. We also do a lot of life science and biology experiments. In this experiment, I've got a container with a Japanese red-bellied newt. You can kind of see the red belly there. And the newt would lay eggs. We put the eggs in little chambers off to the side and just watch and see how they grow and develop in zero gravity, looking for anything unusual that may happen. So we do a lot of experiments with little animals and plants up there. I've flown with goldfish, jellyfish, guppies, salamanders, rats, fruit flies. We're always taking things in space to see how they grow and how they behave in zero gravity. This is Chaki Mukai. She was the first Japanese woman in space, and I flew with her on my first mission. And in space, you don't walk around like we're used to doing here on Earth. In space, it just takes a little push with your finger, and you go sailing through the air like Superman or Superwoman. And you'll keep sailing until you hit a wall or until you reach out to stop your motion. If you like doing somersaults, you can start flipping in the air. And you'll go round and round all day until you get tired and you reach out to stop yourself. So what do you think? Does it sound like fun up there? We have a blast. It's a lot of fun floating around. Here's Susan, the pilot on my last flight. And Susan's typing on a laptop computer there. And I want to point out one feature. If you look at her toes, she's got her toes hooked on that vertical gold pole. If she didn't do that with her toes, what do you think would happen every time she touched the keyboard on the computer? She'd go bouncing off, right? It's one of Newton's laws. For every action, there's an equal and opposite reaction. But if she just pinches that a little bit with her toes, she can stay in position, float in the air, and type on the computer all day long. So space is a really fun, comfortable environment to be in. And in space, there's no up or down. I think we pretty much agree which way is up and which way is down here this morning. In space, there is no up or down. And you know here on Earth, if you stand on your head, all the blood rushes to your head because of gravity. I'm sure you felt the pressure from that. In space, that doesn't happen. You go upside down, you feel totally normal. And in space, wherever your head is pointed, that direction is up for you. Wherever your feet are pointed, that's down. So this is Nancy and Kevin on my second flight. And Nancy's looking at Kevin saying, "Hey Kevin, you're upside down." Well, Kevin's looking right back at her saying, "No, you're upside down." This is what Kevin sees. So who's correct? Neither of them or both of them, right? They both think they're right side up and the other person is upside down. So you never feel like you're upside down, it's everybody else in the room. Now in space, most of our food is freeze-dried, and it comes in small plastic packages like you see here. And to prepare a meal, we bring it to this food station. A sharp needle will poke into the food container. We can inject hot water in there, and that dry, hard, freeze-dried food will soften up, and after a few minutes, it's ready to eat. Then we just cut that plastic package open with a pair of scissors and eat it with a normal fork or spoon. We've got a wide range of different foods up there. Here's some of the vegetables: asparagus, broccoli, and gratin. We've got these freeze-dried strawberries. When you would add water to these, they would turn bright red. And when I would cut the package open, I could just smell the fresh strawberries. So I really like frying those in space. We've got macaroni and cheese, spaghetti and meat sauce. We have these hamburger patties that are hard like a rock. I think you could pound a nail in with them. But once you add hot water to them, they soften up and they're almost edible then. Almost. Now for drinking in space, you know, we can't drink out of a glass or a bottle like we're used to doing here on Earth. If I had this bottle of water in space, I could take the top off, tip it upside down to get a drink, and nothing would happen. Without gravity, the water's not going to fall or pour out of the bottle. So in space, we drink out of these foil pouches that you see here. And they have powdered drinks in them. We've got powdered fruit drink, powdered orange juice, powdered coffee, powdered tea. And we bring that package over to that food station. Needle would poke in there. We would inject the water. Then you mix up the powder, poke a straw in there, and just squeeze it into your mouth. I'm sure you guys have all had juice pouches and juice boxes, right, when you were younger. That's exactly how we drink in space. And here I've got a bag of Tropical Punch in my hand, and you see the red straw with some of the juice in it there. And I've squeezed that bag of punch, and some of the juice got away from me. And what looks like a little red golf ball in front of my face there is actually a blob of Tropical Punch. Any liquid in space forms a perfectly round ball. It's from a force we call surface tension, right? It drives it into a sphere, and it'll just float like that right in front of you. And you can go up to it and gobble it up. Our more polite astronauts will take a straw, you can poke it in there and drink it. You'll see that blob get smaller and smaller and smaller and disappear. So the surface tension force, you know, we don't see it very much here on Earth because gravity dominates. If I took this water and I poured it on the floor or the table, it flattens out because of gravity. But once you're away from gravity, the next strongest force is that surface tension that drives it into a sphere. And sometimes you'll see this. In fact, after it rains, if you look at the leaf of a plant, sometimes you see little drops of water, forming little round balls. That's surface tension. And space is a great place to do studies on that. Now, exercise is really important in space. As I stand up here in front of you this morning, I'm using my leg muscles to walk around, to fight gravity, but in space, it's just a little push with my finger and I sail through the air. And everything is weightless in space. I can lift this podium here with one finger in space. So we don't use our muscles at all, and it's very important to exercise up there. So we have this bicycle we ride every day for about 45 minutes. Get your heart muscle going, get your leg muscles working, so that when you come back to Earth at the end of the mission, you're still in good shape. And right above me, when I would ride the bike, there were two big windows on the shuttle. One was right there, and one's right there. And as I would pedal the bike, I could just lean back and look out the window. And as you're pedaling away, maybe you see Australia go by, or Africa go by the window. In 45 minutes, we'd go halfway around the world. Some of the astronauts used to make a big deal about it. They would say, I want to bicycle across the Pacific Ocean. If you ever hear that claim, don't be impressed. It only takes about 15 minutes to do that. Sleeping is a little unusual in space. The inside of the space shuttle is pretty small, maybe the size of your kitchen at home. And we didn't have dedicated bedrooms, so when it was time to go to bed, we would take a sleeping bag, attach it to the wall, float up there, slip inside, zip it up, and we'd go to bed. We wear the dark eye shades that you see in this picture because we go around the Earth every hour and a half. And you get 45 minutes of daylight, 45 minutes of nighttime. If you don't want the sun coming in your eyes all the time, you need to wear the eye shades there. And you see how our astronaut has his arms crossed like this? Here on Earth, with gravity, if I totally relax, my arms are going to fall to my side, right? But in space, if you totally relax, the natural position of the body is a little hunched over, and the arms tend to come up and float right there. So can you imagine you wake up in the morning, you open your eyes, and the very first thing you see are two hands floating in front of your face? Our astronauts are not that brave, so we tuck our arms in. And the real reason we do it, you see a lot of cables and switches off to the side there. And you don't want your arm in the middle of the night floating over there, bumping a switch, hitting a cable, doing some damage. So we just try to get nice and secure like you see here. Now for cleaning up in space, we don't have a bathtub, we don't have a shower, we don't even have a sink like you have in your kitchen or bathroom at home. So when it comes time to clean up, I showed you some of those drink bags where we have our drinks in, and we have a few of those. Instead of having powdered juice in them, we'll have powdered soap. So we can add hot water, mix up a bag of hot soapy water, we put it on a washcloth, and just give ourselves a sponge bath. For washing our hair, we have a special shampoo that you see here. It's called No Rinse Shampoo. And this was developed for people who are in the hospital who can't get out of bed to take a shower. And it's very easy to use, doesn't require any water. All you do is squirt it in your hair, you work up a lather, and then you take a towel, pat it dry, and you're done. I took this picture, I love the bottom line right there. It says, for beautifully clean, full-bodied hair. And I want to share with you what that looks like in space. Here's Susan, our pilot, and anybody with longer hair, it's going to float all over. And I'm not picking on Susan here, even my short hair floats all over. And we have a saying in space. We say that every day in space is a bad hair day. And that's pretty accurate. I want to share with you the granddaddy of all bad hair days in space. You guys ready for this? You sure? Yeah. You better hold on here. This is Marsha Ivins. She flew on 5 shuttle missions, had super long hair as you see. She wouldn't leave it like this normally, otherwise for the rest of us, it'd be like scuba diving through seaweed. She'd put it in her ponytail, but just did this for the picture. I forgot I had this one in there. You guys know what this is? Yeah, skip this. Skip it? You guys want to hear about this? This is a good group today. Okay, this is the toilet on board the space shuttle. It's in a small closet area, very similar to an airline toilet. We have a curtain that goes across the front for privacy, and you see a toilet seat there like our toilets on Earth. But here on Earth, we use gravity to collect the waste material, right? You can probably imagine what would happen in space, and I won't be talking about that this morning. But this toilet is like a porta potty that you may see at a football game or a construction site. And in the bowl of the toilet here, we have giant fans. And to activate the toilet, there's a little knob off to the side. You push that forward, it activates those fans, and it sucks air from the toilet seat downward. So we use that down rush of air to act like gravity to keep all the waste material down. And that's the secret of our space toilet. My favorite part of this picture is a little card up there with writing on it. Can anybody guess what that might be? Instructions? Exactly right. That's a procedure for how to go to the bathroom. Now, how stupid are these astronauts that you need a procedure to tell you how to go to the bathroom, but we have a procedure for everything we do in space. You've been in the simulators here this week, right? So you've been working with procedures. We even have a procedure for how to go to the toilet. And it sounds kind of silly, but on my first flight, somebody didn't follow the procedure. They broke the toilet. We were able to fix it, but it really points out the importance of following the procedure every time. I'll wrap it up by showing you some pictures of the Earth, and whenever an astronaut has a free moment, we would float to the window to watch the Earth go by. I've got a map in my hand here. I'm trying to figure out where we are around planet Earth. And I'm looking out one of the windows there towards the tail end of the space shuttle. And I took a camera right up to that window, I pressed it against the glass, and I took a picture so you can see exactly what my eyes are seeing. And this is the view I see out the back. So there's a beautiful blue Earth from 300 kilometers above. All the blue in this image is the Pacific Ocean. The white areas are puffy clouds. This is Baja California, part of Mexico here. Yeah. So San Diego, California would just be to the upper right-hand corner of that picture. Now, if you look carefully at the bottom edge of the Earth there, either to the right or to the left of the space shuttle, you may see a little thin blue line. Can you see that today? Any guess as to what that blue line is? That's our atmosphere. On a nice sunny day like we have today in Huntsville, you look up at that blue sky, it looks like it goes on forever and ever. From space, we're looking at that atmosphere edge on. And it looks just like you see here. It looks like a paper-thin layer. Most of the air protecting us here on planet Earth is in the first 20 to 30 kilometers or so. And that's about it, which is why when we pollute the air, it can have such a major impact on our planet. Here's a big hurricane. I saw many storms when I was up there. This was a big one over the Pacific Ocean, about 600 kilometers across. And we flew right over the center of it. Does anybody know what we call that? The eye. Yeah, it's the eye of the hurricane. And from 300 kilometers up, I could look out the window, look straight down, look right into the eye, and see the blue water of the Pacific Ocean. The next picture will show you the eye looking straight into it from directly overhead, right there. Looks a little like an eye, doesn't it? And as you know, you have very light winds here, just a few kilometers an hour breeze, but maybe 10, 15 kilometers away. This is the eye wall where you get the highest winds. And this was a powerful Category 3 hurricane, had top wind speeds of like 200 kilometers an hour. Here's a volcano, venting steam. This is in the South Pacific near Indonesia. Here's another volcanic crater, half underwater there. And here you see the Himalaya mountains. And right at the center there, that's Mount Everest, tallest mountain on planet Earth. Now, I can stand up in front of you this morning and tell you without lying, I have seen the top of Mount Everest with my own eyes about 25 times during my missions. I'm sensing you're not too impressed. I call it the lazy man's way to see the top of Mount Everest, right? No climbing involved. But I use this picture to illustrate some of the things I got to see and do during my career. I've never climbed Mount Everest. I never will in my lifetime. But I've seen the top of it many times, during my missions. I've seen the Great Barrier Reef off Australia, the Amazon rainforest down in Brazil and South America. I've seen Mount Kilimanjaro, big volcanic peak in Africa poking up through the clouds. So many amazing sights around planet Earth. And here you see a sunrise from space. Because we go around the Earth every hour and a half, we see 16 sunrises and 16 sunsets every 24-hour day in space. So I would try to catch as many of these as I could every day. Well, at the end of the mission, it's time to come home. We'd fire 2 engines in the back of the space shuttle, and it would slow our speed down just a few hundred kilometers an hour. And that would be enough for the space shuttle to fall out of orbit and begin its fall back to Earth. It takes 8.5 minutes to get to space, but our fall back to Earth takes about an hour, and then we would end up landing on a nice long runway back at the Kennedy Space Center in Florida. Touching down like an airplane, we would deploy the drag parachute out the back, and then put the brakes on and just roll to a stop. And then we just sit in our seats and wait for them to open the hatch and let us out. And typically it would be about an hour before they let us out of the shuttle. When you first come back from space, you feel like you weigh about 1,000 kilograms. I felt so heavy, because you've been floating around for 2 weeks, and then suddenly you come back to this pull of gravity. So my legs were heavy, my arms were heavy, I was a little dizzy when I got back, and it took a day or so for the dizziness to go away, and maybe a week or so to get your muscle strength back, and then you're pretty much back to normal. So this picture was taken 2 hours after I landed on my first flight. That's me there on the left, and after we took this picture, I turned around, I was looking up at the word Columbia there, and just staring back at my space shuttle thinking, what an amazing vehicle this is. This was my house in space for 2 weeks. This thing protected me from the fiery re-entry coming in through the atmosphere. And then the next thought that popped into my head was, I gotta do this again. And it's like going on a great roller coaster ride. I don't know if any of you do this, where you get off the ride, you run around, get back in line, and do it again immediately. Any of you do that, or just me? Some of you, yeah. That's exactly how I felt. As soon as I landed, I thought, wow, that was amazing. I gotta do it again. And I went on the fly, total of 4 times in space. So our space shuttles are all in museums today. The last flight was in 2011, so 11 years ago. But we still have the International Space Station orbiting the Earth right now, about 300 kilometers up. We've got 7 astronauts that are up there right now. 3 Americans, 3 Russians, and a Japanese astronaut. And typically they stay up there for 6 months at a time. But we're working on a brand new rocket, you probably heard about that this week, called the Space Launch System, SLS. And all the work for that is being done here at the Marshall Space Flight Center. This is where the engineers designing it, testing it out, getting it ready for launch. But these are the biggest rockets that have ever flown, the most powerful rockets. And instead of flying our astronauts in space shuttles, they'll be in capsules on top of the rocket called the Orion. And the Orion capsule will hold 4 to 6 astronauts or so. They'll launch laying on their back, just like I did inside the space shuttle, but instead of coming down like an airplane, they'll come down by parachute, land in the Pacific Ocean, where we'll recover them. First test launch was just 2 days ago, on November 16th. We launched from the Kennedy Space Center, and we launched it towards the moon. It's going to orbit the moon for about 25 days, I heard, like 3 weeks, and then come back. And this flight had no astronauts on board. It's just a test flight. And when it comes back in early December, if everything works well, we'll put astronauts on the very next mission. And that's the Artemis 2 mission. And this mission will have 4 astronauts. We're going to send them in orbit around the moon. So just 2 years or so from now, we'll have astronauts orbiting the moon. We're also going to build a space station called Gateway around the moon. And this is a space station. Astronauts will come from Earth to the space station, and then when they want to go down to the lunar surface, get into a lander and go down from there. And we've got different pieces, an airlock here, habitation modules, and some power and propulsion modules there. So this is still in work. SpaceX and Elon Musk has some of the contracts to build this. So our third mission, Artemis mission, will be Artemis 3, and we're going to land on the south pole of the moon. And NASA's committed to have the first woman on the moon on that mission. So 2 astronauts will land on the moon. It'll be, 1 woman, 1 man. We've had 12 men walk on the moon. You've probably seen our Saturn V moon rocket, the Apollo 16 capsule that went to the moon. We're just a few years away from having the very first woman on the moon. What do you guys think about that? Pretty exciting, right? Yeah. And we currently have 18 astronauts at the Johnson Space Center in Houston that are training for these missions. We got 9 men and 9 women. So you're looking at, those 9 women up there. One of them will be the very first woman on the moon. You're going to hear a lot about her, just in 3 or 4 years from now. And they're going to land down at the south pole of the moon. And what's unique about the south pole there are some very deep craters that the sun never gets down to the bottom of them. And so in the bottom of these craters, we know there's water ice. I think you all know how heavy, like 2 liters of water, it's a pretty heavy container. We would need thousands of gallons of water, thousands of liters, on the moon for our astronauts. If we can use that water ice, to turn into water, and from water we can get hydrogen and oxygen. Oxygen for the astronauts, and hydrogen and oxygen are great rocket fuels. So we know that there's great resources there, and that's why we want to land at the south pole of the moon. We could use that rocket fuel to go on to Mars and other destinations in the future as well. So where are we going with these new rockets and capsules? I mentioned the moon. We'd also like to visit the asteroids and then go on to that red planet. What's that one called? Mars. I always forget that. So here's some artist drawings of these missions. Here's a mission to an asteroid. Scientists would like us to bring back pieces of the asteroid. These are early remnants of our solar system, maybe 4.5 billion years old. Here's a mission to one of the moons of Mars. Mars has 2 small moons, Phobos and Deimos. I think it'd be so amazing to be this astronaut there, and you look over your shoulder and you've got the red planet Mars behind you. In about 20 years, 15, 20 years from now, we're going to land astronauts on the surface of Mars. And this is an artist drawing of that day. You see our landing craft, and just to the right of it, you see the shadowy figure there of the first humans setting foot on Mars. Do you know who those astronauts are? Any guess? I'm too old to go to Mars, okay? 20 years from now, I'm going to be 87. NASA's not sending me to Mars. I'm too old to go to Mars. Your parents are too old to go to Mars. Never repeat this at school, but your teachers and professors are too old to go to Mars. But you are the perfect age. We call you the Mars generation. And it'll be somebody in your generation or your brothers and sisters at home that'll be these first humans setting foot on Mars. And that's why we say, we need you. You all represent the next generation of scientists, engineers, technicians, medical professionals, astronauts, and explorers. We're never going to get to Mars and farther out without your help there. And that's why it's so important for you guys to work hard to do your best in school, because we really do need you. Your countries, we come from many different countries here. They each need you as well, working hard so that you can benefit everybody back home. So with that, I'll say thank you very much, and we got a few minutes for questions if anybody's got a question they'd like to ask. So thank you very much, everybody.